Hello Algebra 2 students, this is your Unit 4 review. Remember to try the problems first and then check your answers with the key, and if you're confused about any problems, that's when you come to the videos to watch those solutions. For the first problem, we're trying to find f of negative 4, so we're going to substitute negative 4 for all of the x's. So f of negative 4 equals 2 times negative 4 to the third plus 3 times negative 4 squared minus 12 times negative 4 plus 7. Negative 4 to the third is negative 64. If you type that in your calculator, make sure that you put parentheses around the negative 4, and then the third power, it goes outside the parentheses. And the same thing with when you type negative 4 to the second power, you should get a positive 16. Okay, and next we can multiply. So this gives us negative 128. Another 48, and 7, and these combine to give you negative 25. Okay, we have 4 parts to these problems. Simplify, write in standard form, state the degree, and state the end behavior. When you have a subtraction problem, remember that this subtraction distributes to everything in the second set of parentheses. So rewrite the first one, 3x to the fifth plus x squared minus 1 minus 7x to the fifth minus a negative makes a plus for x squared, and then distribute the minus to the 3 as well. Now you're going to combine like terms. So I have 3x to the fifth minus 7x to the fifth gives you negative 4x to the fifth, and x squared and 4x squared gives you 5x squared. And negative 1 minus 3 gives you negative 4. Alright, so this is already in standard form. Make sure that this exponent here is a 5, just make sure that's clear. Okay, so this is standard form. It's also simplified, so this is your answers for 1 and 2. Alright, for 3, state the degree. The degree is the exponent, it's the largest exponent, so in this case it's degree 5. State the degree and the type of resulting polynomial. So if it's degree 5, that makes it quintic. And state the end behavior. So because your lead term here is negative, that's telling you that the right side of the polynomial is going to go down. So on the right side, you're going to go down. And because it's odd, that tells you that the ends don't match. So that means that the left side is going to go up. And of course, in the middle here, we'll have a few turns. 1, 2, 3, 4. And the polynomial will look something like this. So now we can say the end behavior. As x goes to positive infinity, that's the right side. The y is going down, so the y is going to negative infinity. And as x goes to negative infinity, that's the left side. The y is going to positive infinity. Alright, here we're multiplying 3 binomials. So start by multiplying 2 of them. I'm going to multiply here. X times x is x squared. X times 2 is 2x. negative 2x, and negative 4. Alright, combining like terms, these cancel out. So now I have x squared minus 4 times x squared plus 3. Alright, x squared times x squared gives me x to the 4th. X squared times 3 is 3x squared. Negative 4 times x squared. And negative 4 times 3. And then finally, combining like terms, right here, I get x to the 4th minus x squared and minus 12. So that's my answer for 1 and for 2, because it's in standard form. Standard form means that the largest exponent term comes first, and then the next largest exponent term going on. Alright. The degree is the largest exponent, so the degree is 4. And that makes it quartic. Okay, let's look at the end behavior. The lead coefficient is positive 1, so that means that the right side is going to go up. And then the degree is even, so that means that the left side is going to match the right side. So they both go up. This is going to be one of the graphs that looks like a W. And your end behavior will be as x goes to positive infinity, y goes to positive infinity, and as x goes to negative infinity, that's on the left side, the y is also going up, so the y is also going to positive infinity. Alright, in problem 4, we need to distribute this binomial to everything in the trinomial, so I'm going to multiply the x times the x squared. That negative, I'm going to leave it outside for the moment. So the negative stays outside, and I have x to the 3rd, and then x times 2x gives me 2x squared. X times 4 is 4x. Now I'm distributing negative 2, so negative 2 times x squared, negative 2x squared. Negative 2 times 2x is negative 4x, and negative 2 times 4 is negative 8. Okay, so now we want to combine like terms. I still have a negative out here. X to the 3rd, that doesn't combine with anything. 2x squared minus 2x squared, so I have no x squareds. And I have a 4x minus a 4x, those combine as well, to cancel out, and I have a negative 8. And then you're going to distribute the negative to each of those terms, so this makes negative x cubed, and then negative times negative is positive 8. So this is the polynomial in standard form. That's my answer for number 2. For 3, the largest exponent is 3, so the degree is 3. And that makes this cubic. And let's see the end behavior. The lead coefficient is negative 1, so that means that the right side is going to go down. So the right side is down. And then the degree is odd, that means the left end does not match the right end, so the left end is going to go up. So this is our end behavior, which means as x goes to positive infinity on the right side, the y is going down, so the y is going to negative infinity. And on the left side, as x goes to negative infinity, the y is going up, so the y goes to positive infinity. Alright, for problem 5, the common mistake is to cube each term, and that just doesn't work. We're cubing the entire binomial, so that means we need to multiply it by itself, and x plus 3 is a factor 3 times. So start by multiplying the first two. X times x gives you x squared, x times 3 times x, and 3 times 3. Combine the like terms. Okay. Now I like to start at the binomial and distribute to the trinomial. So I have x times x squared, x times 6x, x times 9. 3 times x squared, 3 times 6x, and 3 times 9. Okay, so combining like terms, there is no like term for x cubed, so that stays x cubed. 6x squared plus 3x squared gives you 9x squared. 9x plus 18x is 27x, and plus 27. Alright, so this is in standard form, the largest exponent down to the smallest. The degree is your largest exponent. So the degree is 3, which makes this cubic. And the end behavior. So this time your lead coefficient is positive 1, so that tells you that the right side is going up. And the degree is odd, that tells you that the left side does not match the right side. So the left side is going down. So as x goes to positive infinity, the y is going up, the y goes to positive infinity. As x goes to negative infinity, that's the left side, the y is going down, so the y goes to negative infinity. Alright, in problem 6, we're given a polynomial, but we're not told what the coefficients are. But it does tell us the coefficients are integers, so they'll be 1, 2, 3, or negative 1, negative 2, negative 3. And it tells you a is less than 0, so that means that a is a negative number. Okay, so if it confuses you to look at all of these as variables, you can replace them with numbers. And let me just write that down as an example. But the only rule here is that because they tell you a is less than 0, then the a one has to be a negative number. So say we just put in any numbers here. Negative 2x to the third, 3x squared. They don't tell us if b, c, and d are positive or negative, so they can be whatever you want. Okay, so for example, this could be your polynomial. The only part that really matters of those numbers that we filled in is the one they told us. They told us that this lead coefficient has to be negative. So that tells you that the right side of your polynomial is going down. And then you see that your degree is odd, and that tells you that the left side does not match the right side. So the left side of your polynomial is going to go up. Okay, and then you can fill in the middle, but this is generally what your polynomial is going to look like. So your end behavior is, as x goes to positive infinity, you can see the right side's going down, y goes to negative infinity. And then on the left side, as x goes to negative infinity, y goes to positive infinity. Okay, let's turn the page. Okay, so it says sketch the following functions, complete the requested information in the table. graph on the calculator, and then look at the table of values to find accurate points. Be sure to plot all the x-intercepts and the approximate turning points. So we are going to graph this on the calculator, but we can do a little bit of this before we even look at the calculator. You can see you have factors x minus 2, x plus 2, and x minus 1. So those are going to tell you your x-intercepts. So if I set x minus 2 equal to 0, that would give me an x-intercept of 2. And if I set x plus 2 equal to 0, that would give me an x-intercept of negative 2. And if I set x minus 1 equal to 0, that would give me an x-intercept of 1. So I'm going to mark those spots on the graph just to start out. So I have positive 2, negative 2, and 1. Alright, so let's look at the calculator and see what we get. Okay, so press y equals, and you want to enter the equation in your y equals, and then press graph. Okay, so you can see the graph here. I have my points at negative 2, positive 1, and positive 2. You can see it kind of turns very close to the y-intercept, so we need to find out what that y-intercept is, and we want to find out also what that turning point is, and then there's another turning point down here we need to find. So I'm going to calculate this turning point as a relative maximum. Second, calculate maximum. I need to go to the left of the maximum and press enter, and go to the right of the maximum and press enter, enter. Alright, so negative 0.3, 8.6 approximately. So negative 0.3 and 8.6. Right about there. Alright, so it looks like now it goes back down to a y-intercept of 8, and then down here I need to calculate what this turning point is. So I'm going to do second, calculate minimum, and I need to go to the left of that minimum value, enter, and then go to the right of the minimum, enter, enter. So about 1.6, 3.1. 1.6, negative 3.1, 1, 2, 3. So right about there. Alright, so now we want to sketch the polynomial in. It's going to go to the y-intercept right here. Okay, so it should look something like that. Okay, so the reason why the polynomial bounces off the x-axis at negative 2 is because the factor x plus 2 has multiplicity 2, because it's being squared. Alright, the degree. This x is to the first power, this factor is to the second power, and this one is to the first power. So if you add up all of those degrees, you get a total degree of 4. That makes it quartic. The number of real solutions, this solution at negative 2, this one counts as 2 solutions because it's a double root. You can tell it's a double root on the graph because it bounces off the x-axis. And up here in the equation, you can tell it's a double root because that factor is squared, meaning it happens 2 times. So that counts as 2 solutions, plus 1 more, plus 1 more. That's a total of 4 real solutions. So the number of imaginary solutions is the degree minus the real solutions, so that's 0. the x-intercepts. This is where we touch the x-axis, so at -2, +1, and +2. The y-intercept, we saw on the graph that the y-intercept was 8. If you didn't have the graph, you would find the y-intercept by substituting 0 for all the x's. So 0 minus 2, 0 plus 2 squared, 0 minus 1, you should also get 8. Alright, and the end behavior. On the right side it's going up, so as x goes to positive infinity, the y is going up, it's going to positive infinity. And on the left side it's also going up, so the left side is as x goes to negative infinity, and the y is going to positive infinity. Alright, let's check the other one. Okay, and this time I can look at my factors and see that I'm going to have an x-intercept at +3 and at -1. And I'm going to predict that this x-intercept is going to be a bounce because the factor's squared. Don't miss this negative here when you type this on the calculator. Okay, so press y equals and enter your new equation for number 8, and then press graph. Okay, so I can see the x-intercepts that I predicted. I can see a y-intercept over here. It's kind of hard to figure out what that y-intercept is, so I might calculate that y-intercept as well. And then over here I have a turning point, so let's find that turning point. Second, calculate maximum. Enter. And enter, enter. So 1.7, 9.5. Let's see. 1.7, 9.5. Okay, somewhere around here. Alright, to calculate our y-intercept, I can substitute 0 for the x's. So I would have negative 0 minus 3 is -3. And then 0 plus 1 squared. So negative times negative is +3. 1 squared is 1, so 3 times 1 is 3. So my y-intercept is at 1, 2, 3. Alright, so here I had a bounce. And then here I go through the y-intercept, and then I keep going up to the turning point. And then I go back down through my other x-intercept, like that. Okay, for the degree, this first factor only has an exponent of 1, and the second factor has an exponent of 2, so you add those up and you get a degree of 3. The degree of 3 means that the type is cubic. The solutions, I have a double root right here, so that one counts twice, plus one more, so I have 3 real solutions. So you subtract the degree minus the real solutions and find that you have 0 imaginary solutions. Okay, x-intercepts. I have one over here at -1, 0, and one over here at 3, 0. The y-intercept is at 3, 0, 3. Okay, your end behavior. You can always start by filling in as x goes to positive infinity and as x goes to negative infinity. Positive infinity is the right side, negative infinity is the left side. Okay, all of that's always the same. The only part you have to fill in here, and the answers will always be positive infinity or negative infinity. So as x goes to positive infinity, that's the right side. The y is going down, so it's going to negative infinity. And as x goes to negative infinity, that's the left side. The y is going up, so that's positive infinity. Okay, find the zeros and give their multiplicity. So basically you're just setting your factors equal to 0. First one, x minus 5 equals 0. Add 5 to both sides. X equals 5. Second one, 3x minus 2 equals 0. Add 2. 3x equals 2. And divide by 3. So x equals 2/3. And the last one, 2x plus 9 equals 0. 2x equals -9. X equals -9/2, or -4.5. Okay, the first one has no exponent, so you can give it an exponent of 1, and it has multiplicity 1. The second one, the exponent is 4, so it has multiplicity 4. And the last one has an exponent of 3, so it has multiplicity 3. Using the function from A above, state the degree and the end behavior. So the degree is the sum of the exponents, 1 plus 4 plus 3. So the degree is 8. Alright, the end behavior, your lead coefficient is -1. That tells you that the right side goes down. And your degree is even. That tells you that the left side matches the right side. So let's fill in what we always know. As x goes to positive infinity, y goes to. As x goes to negative infinity, y goes to. So as x goes to positive infinity, that's on the right side. The y is going down, so it's going to negative infinity. And as x goes to negative infinity, the y is going down again, so the y goes to negative infinity. Okay, so that's the end of this video. There is another video for the second half of the review.